All right, module 2. Which of the following equations correctly expresses the vertical asymptote of the function below? Okay. This one might be kind of confusing if you're seeing it for the first time.
Yes, sir.
We can
I
go over
didn't
it.
understand what vertical asymptote
Yeah,
here.
yeah. There's a kind of a hard, concept and also word. So, yeah, I'll explain it. So the question is asking for an equation that expresses, so shows the vertical asymptote, something called a vertical asymptote of a function y equals x plus 2, 12 plus 6. So what is a vertical asymptote? We'll start with that. So let's say we have a x and y plane, and then we say there's a certain kind of equation that when we graph it has a form of this. Let's say this is equal to some kind of function fx.
Yes.
Yeah. So you'll be able to see that in the x direction, it never goes below these x-axis, right?
Yes, sir.
So the y value will constantly be getting closer and closer to 0, which is on this
Zero,
line,
but
right? But it never
yes,
touches the
but
line.
never crosses it.
Yeah. And then if you look at the other side here, you can see that it keeps going up and up, but it never touches the y axis. So this is a function that the x value, so value here, is never less than or equal to 0.
Yes,
So when we have a certain point or value that it never reaches, so in this case is when x, it will never reach 0 because it gets closer and closer, but it never really touches. This is what we call an asymptote. And for this, and you can see that the line I'm drawing is vertical, right?
yes, sir.
So a vertical asymptote just means when we draw a graph for a specific equation, you'll be asking, so it'll be the kind of the invisible line that the graph never crosses. Do you kind of understand that definition or
Yes, sir. I got.
yeah?
It's approaching to zero, but never reaches zero.
Yeah, that's exactly it. So it approaches, so the graph, the x value, as we're getting smaller and smaller, it approaches 0 but never touches. So the vertical asymptote will be when x is 0 and going vertically. Yeah.
Yes, sir.
So if we take a look at the equation that the question gave us, and we try to draw it, you can use decimals for this. In my case, I will be kind of showing you how you could kind of sketch it using intuition a bit. So you can see that the x is in the denominator in the below here. So let's just have a simple number. So when x equals 0, what will be the y value? So when x is equal to 0, y will be 2 over 12 plus 6, which is equal to 6 plus 6, so 12, right?
Yes, sir.
So it'll be 12 when x equals 0. So there'll be a point here. And then, let's just try going to the right first. If we increase x incrementally forever, we can see that because x is in the denominator, as x
Yes,
increases, the entire value of y
decreases.
kind of goes down to 6.
Yes,
Because this part will, as x gets bigger, will start to approach 0.
yes,
Because if denominator is like 1,000, but the numerator stays the same as 12, then, and if the denominator keeps increasing onto infinity, then we can kind of say it's 0, right?
yes, sir.
So as x increases in the positive direction, the y value will start to approach 6, but never touches the line 6. So it keeps on decreasing. Yeah,
Yes.
and approaches 6. This will be what we call a horizontal asymptote. Because it's a asymptote that is in the horizontal direction. Do you understand?
Yes, sir.
Mhm. But the question for this question is asking for the vertical asymptote. So we can see that as x is continues to approach, let's say it starts going into the negative direction. Yeah. So a kind of key point that you should remember. Yes, if you draw it in decimals, it'll kind of tell you, but then mhm. If we have a function of x and is in the denominator, such as this case,
Yes, sir.
so when a zero is in the denominator, it means it is a value that cannot be defined. So it cannot exist because you cannot divide a number using zero, right?
Right. Yes, sir.
Yeah. So if there's a situation where this happens, then that means the value of x in which that happens, it will be the point where the asymptote is, kind of. It's kind of hard to understand, but in this case, x plus 2 equals 0 when x is equal to negative 2, correct?
Yes, sir.
Yeah. So if we have, let's say here, negative 2, then as the graph approaches x equals negative 2, you continue to increase, but never touches.
Yes, sir.
So we can kind of think of it as if x is equal to negative 1, it'll be 12 over 1, so 12 plus 6, so it'll be 18. So this will be 18. So it keeps on increasing, but why doesn't it touch or go over this invisible asymptote? Is because if x is keep on getting smaller and smaller, the denominator will, let's say it approaches 0.001 plus 6. Then when x is equal to negative 1.999. So it isn't negative 2. It's a bit bigger. This will be a much bigger value, such as 1206. I think
Yes, sir.
one more zero, or yeah.
Mm.
So you can see that it keeps on increasing and increasing for the y value, but it never crosses negative 2, the asymptote.
Yes, sir.
Do you kind of understand this?
Yes, sir. I got it.
Yeah. So these two lines are called, one is called the horizontal asymptote, and the vertical one is, as you guess, the vertical asymptote.
I got it.
Mhm. Yeah, and if we draw this on the decimals calculator, it actually kind of has a form of this. So there's another part that's here. Mhm. So
Yes, sir.
this, you don't have to worry about having to draw it on your own because you can use the decimals calculator.
Yes.
Yeah, and when you draw it, you get a graph that looks like this. And so you can see that for both this part and this part, they never cross the line of x equals negative 2.
Yes, sir.
Mhm. And because of that, we can know that the line x equals negative 2, so this line here, is the vertical asymptote.
Yes.
Uh, any questions? Because I know this could be very confusing.
Mm. No, sir. It's clear.
Is clear to you?
Yes. So, sir, we are getting x equals negative 2 because minus 2 plus 2 equals 0. So, it is reaching near infinity or
Yeah, that's exactly it. So as let's say x is approaching negative 2,
yes,
so it never equals negative 2, but it gets close to it, so like negative 1.99999,
sir.
then this bottom denominator here will continue to get smaller and smaller so that this
Yes, sir.
whole part with the 12 on top will begin to approach infinity, correct?
Yes, sir.
Yeah. So even if x does not equal -2, if it's a bit bigger than that, so coming from the right side, it approaches positive infinity for the y value.
Yes, sir.
Yeah. And if it comes from the right, so let's say like -2.0001, so a bit lower than -2, you can see that this bottom part will be uh where
Fine.
mhm. Yeah. So this bottom part will kind of reach -0.000, a lot of zeros, 1 and 12 on top. Yeah. So this can be rewritten as 12 times negative with a lot of zeros. You understand, right?
Yes, sir.
So technically we can say this is approaching negative infinity, which is shown in this part. It keeps on going down and approaches negative infinity.
Yes, sir.
And the reason and for when x equals -2, there is no value that exists when x equals -2. Because if x equals -2, it would have been 12 over 0 plus 6. But we know from fundamental rules of math, you cannot divide any number by 0 because that will give you no numerical value. So
Yes, sir.
because this cannot exist, this whole thing cannot exist. Do you kind of
Yes, sir.
understand? Yeah.
Yes, sir.
So that's why it always approaches a specific value for -2, but -2 itself does not have a specific value. So that's why it's called a asymptote.
Oh, so yes. So -2 is asymptote here.
Yes, x equals -2, this vertical line.
Yes, sir. We are finding the vertical line.
Yeah.
Got it, sir.
Yeah. So x equals -2 will be the final answer. Do you understand?
Yes, sir.
Okay, okay. So we can move on to the next question. Right. When at print number 14, printer starts printing, it loads document data from a computer and prints out the document. Ahmed's printer always takes 12 seconds to load data and prints 10 pages per minute. Which of the following functions correctly models the time t in seconds it takes for Ahmed's printer to start loading a document and complete printing p pages? Okay, okay. For this question, was it kind of the long explanation that kind of was difficult for you, Nawarj?
Sorry, sir.
Uh, uh, what kind of part did you have trouble with for this specific question? Do you remember?
What sir, I can I tell my thought process here in this question?
Yeah, you can. Yeah, please explain.
So what I thought is it is taking 12 seconds. So it could be like I think I thought it as a constant. I suppose
Mm-hmm.
12 seconds, and as it prints 10 pages per minute, so it's not going to be the constant. And I think I chose 10p. So it
Mm-hmm. Ah, okay, okay. Okay, okay, yeah. So I'll explain. So a key part of questions like this is figuring out what it's asking for, and it kind of gives you characteristics and values in words, so it's kind of hard to like initially kind of understand. But then if you go through it, so first of all, what the question is asking for. So it's asking for a function called t in terms of p, and this has to explain the amount of time in seconds to print p number of pages with this person's printer, right?
yes, sir.
Yeah. So in the question, it says the printer always takes 12 seconds in order to do what? In order to load the data for before printing. So yeah, so you'll be using, so the printer will be using 12 seconds always, no matter the amount of pages to load all the data.
Yes, sir.
This, like you said, thought correctly, is will be the constant for our equation. Because in the question, just says it always takes 12 seconds to load the data, right?
Yes,
So
sir.
it will not depend on the number of pages, P. Mhm.
Yes, sir.
That's why it will be a constant. And then reading more, the printer prints 10 pages per minute. So 10 pages per 1 minute.
Mm.
And we know that 1 minute is 60 seconds.
Sir.
So in order to print one page, it takes 6 seconds, correct?
Yes, sir.
Mhm. And so the question asks for uh, how long to write an equation for uh, printing P number of pages. So P will be the variable. And
Yes,
so
sir.
in order to print P amount of pages, we will just speak, because each page takes 6 seconds, it will be 6 times the number of pages.
Yes, sir.
Yeah, you understand? So this is how many seconds it will take to print P number of pages. So we have this part, and we have
That constant part.
this part, the constant part, right? So what we do to find the equation, the amount of time it takes to print P number of pages, is the loading time, which is always 12 seconds, and then 6P.
Yes, sir.
Yeah. So, mhm. So this will be the final equation. Mhm. You kind of understand
Yes, sir.
this
I
part?
understand.
Yeah. So yeah, just make sure to read the question carefully to fully understand what it's saying. Mhm.
Yes.
And so yeah, you can kind of know what will be the constant. So in this case, it was 12 seconds of loading. And then what if a question gives you like example of like this, 10 pages is 1 minute, and we need everything in seconds, so we convert 1 minute into 60 seconds.
Yes.
And then because we need to know how many P pages, we first need to know how long it takes for one page to be printed.
Yes.
Yeah. And then in order to find P pages, you just times it by P. So it'll be 6P seconds. So
Yes.
everything added up here will be 12 plus 6P seconds in order to print P pages.
Yes.
Yeah. Any questions for this one?
No, no, sir. I
No?
clearly.
Okay, okay. Yeah. All right. Let's quickly move on to the next one. We have two equations. Which of the following coordinates satisfies the system of inequalities above? Okay. Now this one's the wording is kind of confusing, right?
Yes, sir. I put this on Desmos, and I think
Mhm.
I got 8, 10 as an answer.
Okay, 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 yeah. So I'll explain let's see. Yeah, how we can kind of prove this and go through it, how to approach this kind of question. So it gave us first equation y equals, no, sorry, not equal, but y is greater than 1/3 x plus 7. And then a second inequality, y is less than 2x minus 4. Mhm. So what would these kind of look like in if we had graphed them, let's say? So this first part, first equation, if we graph it, mhm, let's have a x and y plane. Then we first write y equals 1/3 x plus 7, which is, let's say 7 is here. We have an equation, a graph that kind of looks like this.
Yes, sir.
But this is y equals 1/3 x plus 7. But in this part, it says it's greater than, right?
Yes, sir.
So when what y is equal to this value, it is this line. But when it's greater, it will be the part that
Yeah.
is above.
Yes, sir.
Do you understand?
Yes, sir.
Yeah, so if it said, for example, y was less than 1/3 x plus 7, it would be the bottom area.
Yes, sir.
Mhm. So let's graph the second one also. Oh, Let's first graph y equals 2x minus 4. So let's say minus 4 is here. Then 2x will be like this. So this will be y equals 2x minus 4. And we need the y to be less than this value.
Yes, sir.
So it means it must be lower, which is this
Down
area.
upward of this.
Yeah, this corner. So technically, we can say that is this whole part, right?
Yes, sir.
Yeah, because it's less than. But the question is asking for when both of these are true. So the
So that
value,
yeah.
yeah, the y values has to be in both this top area and this bottom area, which will be this area.
Yes, sir.
So this area, both of these equations go through. So we'll be finding points that are within this specific area.
Yes, sir.
You kind of understand?
Yes, sir.
Yeah. So this is a graphical view of what we're finding, and a way we can solve it using equations is just we can combine these two inequalities. So if we put y in the middle, y has to be less than 2x minus 4, right?
Yes, sir.
But it also has to be larger than 1/3 x plus 7. Uh, sorry, one moment. Okay. Okay. So because of this 1/3 x, it's kind of difficult to plug in numbers. So we'll multiply everything by 3. So it'll be x plus 21, y, and that is less than 6x plus minus 14. You kind of
Minus four.
understand? We converted that into that.
Yes, we multiplied by 3, sir.
Yeah, multiply everything by 3. And so it's kind of hard. So my tip for questions like this, the answer choices give you specific points, correct?
Yes, sir.
So the easy way is to really just plug in each of those points within this entire relationship and make sure it is true.
Yes.
So that this part is smallest, this is in the middle, and this is the largest, right?
Yes, sir.
Yeah. So let's put in D, which is I believe the correct answer. Yeah. So it would have been, the D was 8 comma 10. If we plug this into here, we get 8 plus 21, 29, less than 3 times 10, which is 30. And then here, 6 times 8 will be 48 minus 12, so 36.
Yes, sir.
Do you kind of, yeah, so I just plugged in X and Y into this to get this.
Yes, sir. It is satisfied.
Yeah, so it satisfies this relationship, which is this. So this was choice D. Let's do another one with the wrong answer. So such as choice A, which is 1 comma 12, right?
Yes, sir.
So let's just plug this in to see if the relationship still is true and holds. So X is 1, so 1 plus 21 is 22. And bigger than that is 3 times Y, which is 3 times 12, so 36. And then put 1 again, it will be 6 minus 12, which is minus 6. Oh, but this does not make sense, right?
Yes, sir.
Yeah, so that's why A is cannot be the right answer,
Yes.
because it does not, the values of A does not satisfy this relationship.
Yes.
So yes, it might take a bit of time to plug each one and find the numbers, but once you do, you see that D is the only correct value that satisfies the relationship. So that's why it will be D.
If we have to do through Desmos, we have to find the points here, right, sir?
Yeah. So what you so for in the case of Desmos, what we can do is, let's say you plugged it in and you found that the value you needed was, one moment, this part, right?
Yes, sir.
So what kind of point would this be? You can see that there's an intersection here. Yeah.
Yes, sir.
So values here will be, so let's say this is some kind of x0 and y0 for the intercept. For any point here, the x must be, let's say there's an x comma y here. The x for the point must be greater than the intersection x, and the y for the this point should be greater than the y for the interception.
Yes.
Yeah. So you can kind of use this relationship as a guide to go through each answer choice and see which one satisfies it.
So is it better to do with paper or Desmos calculator?
Uh, I would recommend to do paperwork like this. And the reason for that is because, let's say, so what we're trying to say is that, so technically this two relationship is talking about this area. So it's not the perfect area, right?
Yes, sir.
Because there might be points, you might find points that satisfies this, but are actually in this part, which is not part of the area that you need to find, right?
Yes, sir.
So that's why this could be a guide, but it might still show a wrong answer to be true. Yeah.
Ye-
Mm. So
Yes, sir. I got.
yeah, so if you found a answer using paper and if you wanted to check, then you can use Desmos to see, oh yeah, the value I found, 8 comma 10, is probably in this part of the area. So I suggest using Desmos to check your final answer.
Yes, I got it.
Mhm. So you have any questions regarding this equation part, the paper part?
No, sir.
No? Okay, so then we will move on.